There, I'm recording. Okay, so before we get into what I want to show you is that when we graph these transformations, what we're going to do is something that's similar to, yeah, good. Hello, this is actually the F period class that's doing this right now. So, but anyway, I want to talk about a way that we can graph these. One of the things that we did in the other class is I said, let's see if we can't reposition the zero because we always had these shifts. Like for instance, on this one here, we have this, we have a shift of, come on there, buddy. We have this shift of +3. So what we can do instead of predicting that shift is what we can do is start with the parent function, and then for every x value, we can add the 3. So, for instance, on number 9, I think we did number 9, right? Okay. So just kind of watch what I'm doing here, because what I'm going to do is I'm going to copy this. I'm going to do the same idea when we get to the more advanced problems, the last 4 questions that we have on this packet. So let me just show you how we're going to look at this. So there's 2 things that happen in this graph, if you remember. One is that we have a shift to the right 3 for every x value. So every x value moves to the right 3. And then every y value does what? Okay, so every y value, we add 4 to it, right? It goes up 4. Remember that y and f of x mean the same thing. So what I want to do is on this little chart here, on this little t chart, which is much bigger than a t right now, I'm going to go ahead and write my x plus 3 over here. And over here, what I'm going to do is remind myself to add 4 to every y value. So the parent function of number 9 is what again? Exactly, absolute value. And what I'm going to do is I'm just going to use those 5 critical points. Again, do you guys remember the ones that we started with? The most basic points? Do you got them now?
We did different last time.
Okay, we did do that for that?
We did 1, 2, 3, 4, 5 because of the shape.
Correct. But what I'm going to do is I'm going to do it a little bit different on this one. All right. They don't ask me to do this in the instructions, but what I want to do is I want to use this. We didn't do the last 4 graphs, I believe, from class.
Yeah.
So what I want to do is I want to give you a brief introduction to what we're going to do at the end. Okay. So I'm going to start with something relatively simple. So, and then for the parent function, the absolute value of -2 is 2. Absolute value of -1 is 1. 0, 1, 2. So these numbers here that I'm highlighting, right? That's a horrible highlight. But anyway, these numbers here that I would have highlighted if that highlighter wasn't so ugly are the basic parent function numbers that we get from the very, very first page. Okay? So what am I going to do? I'm going to take each x value and I'm going to add 3 on that left column. So you see my left column? What's -2 plus 3? 1. I don't like that color. 1. And then -1 plus 3? 0 plus 3? 1 plus 3. And then 2 plus 3? Okay, notice those are the numbers that we used yesterday, right? Our last class. So this is our new way of doing that. Now what I'm going to do is see what happens from the parent function, what happens to the y values. Well, each y value gains 4 too. So I've got, let's go ahead and take these values here and add my 4. So 6. Next. Wait. What did you say? It's 5 again, right? 5, 6. So what I'm going to do is graph these x values, these new x values, and these new y values. So basically what I did, again, is I started with the parent function, and what I did is I looked at the equation to figure out what happens to all the x values. Well, every x value adds 3. What happens to the y values? They all add 4. So this is a different way of doing what we did the other day. Okay? But what's nice about this method is that it works for far more complicated formulas.
Do you always use -2, -1, 0, 1, and 2?
Yes. That's the beauty of it, right? So, for instance, let's go to, I'm trying to think if it would be the next page. Well, I'll tell you what, let's do this one first. Okay? Yes? Good timing. Okay. All right. Let's go let's see if we can do the next one. So, again, the parent function is the same, so the numbers that we start with are going to be the same. Right? 2, 1, 0, 1, 2, right? So now, again, what we're going to do is try to figure out what happens to the x values and the y values. First of all, with the x value, what's going to happen here? So you remember, Hunter, that the -1 means a shift not to the left one, but to the right one, right? So that means that all our x values are going to be one more, right? So over on the left side, we're going to have x plus 1. This minus sign may not be so clear about what it's doing. The minus sign actually takes the y value and makes it negative. Okay? That's how it flips. Remember how it flips? And so to make it flip, the x values don't change, it's the y values that change. All right? Because no longer are we using the y values that are positive, we're using the y values now that are negative when we flip the graph. That kind of makes sense? So I'm going to tell you that anything that goes on in this area before the absolute value, anything that goes on in this area before the absolute value is related to the y. So what I'm going to want to do is, for my y value, is I want to multiply by -1. If that makes sense, or however you wish to do it. So let's go ahead and do that. So let's go ahead and add 1 to all my x values. -1, 0, 1, 2, 3. Same numbers we got last time, right? And now I multiply all those y values, right, times -1. So I get -2, -1, 0, -1, -2. Do those look like the exact same numbers that we had before? Okay. But do you see how, even though this may take a little more time, do you see the kind of method that we're using? We're saying we're starting with this parent function, and this is what we're doing to all the x values, and this is what we're doing to all the y values based on our looking at the formula. Are we doing all right with that? Okay, I didn't graph those, but actually I could. It's going to be -1, -2. Is that right? -1, -2. And then I have 0. Again, we're using these values as the x values, and we're using these as the y values. So 0, -1. Stop it. 0, -1. And then we got 0, 1, 0. And then we have 2, -1. And then we have 3, -3, -2. And so there's our graph again, right? Same graph. Slightly different method. So What's nice about this method, it's the exact one you're going to be using for those of you daring enough to take pre-calculus next year. Let's go ahead and, if you look at the previous page, we did this, okay? And, but we just did it, we created the numbers in our head, these ones here. So what I'm doing is giving you a more of a method to produce those numbers. So we're not really, we are doing what we did, we're just doing it in a slightly different way. Okay? So moving back to another chart, all right? And let's see if we can do this one. All right, so let's go to number 12. Do it together. Let's see if we can remember the parent function values for the x squared, the quadratic parent function. The x values, we're going to start with -2, -1, 0, 1, 2. So we get those 5 basic points. And we need to square all of them, right? So -2 squared is, we're not going to do anything yet. We're going to do the parent function first. So the parent function, the basic parent function is the very first page of this packet. The very, very first page on the right-hand side, you'll see this one. And so the parent function is 41014. And you'll get more and more used to that. Clearly I did. So now, what will I be doing to my x values here? I subtract 2. Remember, it's the opposite of what we see up there. Subtract the 2. What do I do to my y values? Yeah. If I want to get like weird, I can do it this way. I could go f of x plus 5, right? So, filling in the chart, -2 minus 2, -2 minus 1, -2, 0, -2 plus 1, and -2 plus 2, 0. I don't know about you, but I kind of like this method of transferring the graphs. I could easily do this on a weekend. Evo, you doing well today? Did you start the morning a little too early today?
Yeah.
What time did you wake up? You're too tired to see the clock?
Yeah.
Oh my God. I can't imagine doing the workout you guys must do that early in the morning. Could you imagine doing a football workout at 5:30 or something? No, that's what they do, though. They have the hockey players. And then they have to, so you practice this morning, and then they have to pack and get on an airplane tonight, go to Boston, and then play a game. What time's your first game tomorrow?
First game is tomorrow, 9.
In the morning. Okay. Do you guys get a feel for these poor... It doesn't. There's no time change, thankfully.
We are leaving after lunch, so it's one.
Yeah, right after lunch.
Oh, you'll probably get there like 6, yeah.
Anyway, don't feel sorry for them because, someday they may be able to buy you lunch with their hockey playing, but anyway, it's a lot of work. It's hard. Okay, let's go to this next one, all right? So I add, Hunter, I add 5 to each one of my y values. 4 plus 5? 9. 1 plus 5 is going to be 0 plus 5. And look, it just repeats itself. And so, again, if we graph the first numbers and the last numbers, you're going to get the transformed graph. You guys ready for the yeah?
So do we always use for the values -2, -1, 0?
Correct. So the question is, the question Kenza asks is, do we always use the same values of the parent function? Answer, yes. because the idea is that we're starting with the parent function, and that we're changing the x values and changing the y values to produce its progeny.
So the y of
So this is its
quadratic-
child. What's that?
The y of a quadratic is 4, 1, 0.
Correct. Yeah, so this part is the same every time you do a quadratic. Same for all quadratics. Would you like to do that? Okay, now on this one, you got that negative sign in front of the x, which does what? It's going to flip it. So that means, so first off, is there anything happening to the x value?
It's being squared.
It's being squared, but it's not in parentheses, right? It's not one of these. It's not one of these x plus 3 squared things, right? It's really kind of like x plus 0 squared. So is there any shifting going on? No. So what's nice about this one is the x values will not change. Okay, on the left side. But what two things happen to the y value? What are we going to do to the y value? Plus 8 means it's going up, right? And then what else happens? Is it's becoming negative. Right? So all my y values have to change sign. So let's go ahead and get the parent function values for the quadratic. It's going to be -2, -1, 0, 1, 2. Those numbers are the same for all our parent functions, right now. And then 4, 1, 0, 1, 4. So let's, my x values do not change. There's no shifting in the x-axis. What's that? I want to add 8, though, to the y values. All right? It's not, okay, distinguish this from that. This, what I just wrote here, means to the left 8. Here means up 8. And up and down, remember, is the y. Right? So that's why over here, Kenzai, I have the plus 8. All right? As that we're going to add that to the y value. We're going to move it up 8. And then we're also going to make it negative. So what's 4 plus 8? It's 12. And then we minus it, it's minus 12. All right? Take the 1. 1 plus 8 is 9. And then make it minus, right? What are the next 3 numbers? Madeline, want to give me the next one? Go ahead.
So, from what we did on Tuesday, is that like a different method?
If you learn this method, you may replace what we learned on Tuesday. Okay? This is the same, but what this is going to allow us to do is it's going to allow us to do what we did on Tuesday, but it's also going to, but it also replace it. As you can see, it's pretty much, it includes what we did. If you look at the previous page, for instance, to this one here, so now I said, okay, so in this case, with this one, what we're saying is we're making it negative, and we're also adding 8. So that's what I say f of x. I'm saying this value here add 8, and then make the opposite. So here's a 0. Add 8 and make the opposite. It's going to be what? Negative 8. Add 8 and take the opposite. And then again, you guys see the symmetry that always happens, right? Okay, Evo. Do you want me to graph that one too? Want to graph it? I don't even know if I can fit the graph on there because it's got negative 12 on it. But let's go ahead and we can. So again, when we graph it, yes.
Is there a reason that is it always going to be 4 1 0 1 4?
Yeah, you guys keep asking that, but yeah, it's exactly.
So those the middle two columns are never going to change.
Okay, these middle ones are the same. We're going to use the same ones for every quadratic.
All right.
So again, like I said over there, same for every quadratic. We start with those, and then what we do is we use them to guide us into the transformation. Okay? So we use those basic values, and then we add our numbers or multiply our numbers like that. Okay, so let's go ahead and try to graph it. Remember, we're going to graph the first column and the second column. So negative 2, negative 12, negative 2, negative 12 is somewhere down here. Negative 1, negative 9. You see how we're going from the first column to the last column? All right. Negative 1, negative 9. And then 0, negative 8. No yawning. 0, negative 8's here. I'm sorry. So there it is. Cute little parabola, right? It's not as small. I mean, you can make it big as you want, but that would be the parabola. Are you guys ready for like the varsity type questions here? Did leaving just totally blow you away?
I'm just tired.
Yeah, you guys are all tired, and I'm really making this a very exciting class. I can tell. So, Sebastian is like, "You good? You look pretty awake, though. You're doing good. You're doing all right. It's nice when it works. Okay, you guys ready for something more exciting? Should I just get to the nasty stuff right away, or what? Kenza? No? Do you want do you need a break? Tell you what, why don't you guys take a 5-minute break, all right? Just stand up and stretch, get some hot chocolate or something like that, all right? Is if you look at the function, what's an x squared? So we have to recognize that we have different parent functions, right? We have the quadratic parent function, the linear parent function. We have the constant one, which we don't use much, but we also have absolute value in quadratic. So mostly we're dealing with quadratic and absolute value.
So for quadratic is 4 1 0 1 4.
Correct. So the x values are the same. For the quadratic, remember we're squaring the x values to get the y. So negative 2 squared, negative 1 squared, 0 squared, whatever. So, okay, does that make it better? Does that clear it up, the issue? So that, let me go back a couple. This one, on this one here, do you see on the left, on number 11? On number 11, we did minus it. And that, again, whenever we deal with the minus sign, that is what happens to the y value.
Yeah, but then on the next one you did x minus 2, not x plus 2.
Okay, and why did I put the minus 2? The minus 2 referred to this. Okay, so this part here, remember, was a shift in the left-right direction, which is an x thing. So the key is that we're going to deal with the parent function, and we're going to say, well, going from the parent function, what happens to the x value? For number 12, that x value moves over to the left 2, shifts to the left 2. So anything that's in the parentheses refers to what we do to the x value. Pretty much everything else is what we do to the y value. So the minus sign goes with the y value. The stretch or the shrink will go with the y value. And then in this case, this 5 here also goes with the y value. Okay? So the key to being able to do this is just getting used to recognizing what things go with the x and what things go with the y. What helps you though is that the only thing that really goes with the x is inside the parentheses. Everything else is associated with the y. And once you've done a couple of these, all right, Abby, after you've done a few of these, you're going to recognize what things go with the y and what things don't. Okay? So let's go back to where we were on this one. Let me go back button here. Okay, we're recording again. The vote has been to do the last 6 graphs. So we're skipping ahead. And what we need to do is just be able to, we just need to be able to recognize what things happen to the x value and what things happen to the y value. And believe it or not, you actually know this, but we're gonna have to be a little bit more deliberate about it right now. So if we look at number 15, 15 is an absolute value graph, and you see the 3 on the outside of the x. Now, the question is, does that 3 affect the x value or does it affect the y value in terms of stretching it? And it affects the y value, correct, because it makes it steeper. All right, so a stretch, remember that a stretch is a number that comes before, it refers to a number that comes before those parentheses, in this case. And in this case, it's going to stretch it up. It's kind of like a slope. So we know that we're going to do 2 things to the y value. So what 2 things are we going to do to the y value, and in what order do you think we're going to do them? First thing we're going to do is take the y value, I'll just call it f of x, and I'm going to multiply it by 3, and then I'm going to add the 1.
Oh, add 1. Would it be minus?
So we're going to do it just like, please excuse my dear Aunt Sally, okay? We're going to do the multiplication first, and then we're going to add the 1. Okay? So, do you guys that just came in?
We took 3 times what?
So in this case, what we're dealing with is, this is new for us right now, is that 3. That 3 refers to a stretch, and Abby correctly diagnosed the fact that refers to what we do to the y value. And again, very, very much like simplification, we're going to do the multiplication first, and then we're going to do the minus 1. Remember, the minus 1 here means it goes down 1, right? So we're going to do multiply it by 3 first, and then subtract the 1. What do we do to the x value? Is there anything being done to the x value inside the absolute value sign?
Absolute value, that's it.
No, nothing happening. Yes?
Why is this one 21012 instead of 41014?
Because this one is the absolute value parent function. Okay, so what I was saying before the on this one we have 21012. Okay, because it's the absolute value parent function. So anytime you have an absolute value graph that you have to do, these are the numbers to use. So, and just like Tristan said, nothing's going to happen to the x values. So they're going to stay the same. That -2, -1, 0, 1, 2. There's nothing happening inside those brackets, inside the absolute value sign, so nothing's there. Okay? But let's go ahead and do let's do the y values. So 3 times 2 plus 1.
7.
Minus 1, isn't it? Sorry. Why do I have a plus 1 there?
Yeah, I don't get how you know what to put the x and the y.
What? Because it's an
Okay.
absolute value.
Are you talking about the red ones?
No, I'm talking about the block. Like, how do you know to make it 3 times y minus 1?
Okay, so look at the look up here. Look up the Look at the original, the equation on the top. So remember that this 3 represents a stretch. It affects the y value. So that's why we're going to take the y values from the parent function and we're going to multiply them by 3. What does minus 2 do? Remember that the minus 2 also pushes the graph down too. That's also a y thing. All right? And so that also has to happen to the y values. So coming from the parent function, moving from the parent function to the new function, what we want to do is we want to multiply by 3 to stretch it. That's what stretches it, in fact. And then we're going to subtract the 1 to move it down 1. Okay? So the key thing is recognizing what things do we do to the y value and what things we do with the x value.
Like in the other another one, I don't remember, but we like made a positive and negative. Like we flipped it.
Yes, on the previous one, when we did this one up here. There we are. Okay, so let's go ahead. Let's go ahead and graph these points. So see if we can do this. All right. Can you guys maybe get ahead of me on this one? Evo, you can do this. All right. Let's see if you guys can fill in this column, this far right column. Take the f of x value, multiply it by 3, and subtract 1. I'll go slow. You go fast. Everyone agree with my numbers? Want to graph? So let's graph it. Let's see what happens. Now, in general, I think we should expect something here, right? If you look at the function itself, the function is stretched 3 and shifted down 1. Let's see if that's what happens. So graph the first column with the second column. So the first point is going to be what, Sebastian? Graph in the first point, first column, -2, last column, 5. So -2, 5 is going to be up here, right? And now what's the next point? -1, what? 2. And then 0, -1. See, it shifted down, didn't it? And then it's symmetric, just so you guys know, right? So tell me, does that look like a graph that was shifted down 1 and stretched 3? Yes. Okay? Appreciate something. You just graphed a crazy looking function, right? That's what you need to appreciate. And you graphed it accurately, as accurate. You graphed it as well as the calculator could. Okay. Next one. I don't know if I want to do this. Let you do this one all on your own. I don't want you guys to hurt yourselves, but can you? Why don't we? Where should we start again? Is it the parent function? And the parent function is going to be what, Tristan?
4, 1, 0, 1.
Right. We start with it. Yeah.
-2, -1, 0, 1, 2.
Right.
Then 4, 1, 0, 1, 4.
Okay. So those are the quadratic numbers, right? For the basic function. Now, let's see who can recognize what do we do with the x values, what's going to happen to the x values, and what's going to happen to the y values. So,
Subtract 1 for x, so x minus 1.
I'm going to add 1 to x. Why is that? Not subtract? Because remember with the shift? with the shift, remember it's always opposite, right? That's really a right shift to 1. So we're actually adding 1. Is everyone okay with that?
Mm-hmm.
Okay. So we add 1 to the x. Now, what are the 2 things?
2 of x plus 3.
So we're going to go 2 f of x, 2 times f of x, plus 3. Excellent. Can you guys fill in those values and graph it? And I guess I'm going to pause this. So you guys, in my F period class, I'll pause it. You guys can graph it. And then when you're done, you can press play again, and hopefully we'll have the same graph. So I'll start the recording again. So, yeah, I guess one of the things that might have helped us is filling in this little thing. But the parent function in this case is the quadratic, right? And that's what gives us those values. And anyway, so you got it, you don't got it, or you're not sure? How you guys on this one? Thumbs up, thumb down, sideways? You're good? Good. All right. So which one are we on now? We're almost... aren't we? Okay. Can we do 18? Can we?
That's a shrink, right?
It's a shrink. Yeah, I want to do that one. And it's also we have to approximate the graph on this one, but we're going to do a shrink. And what's the parent function on this one? It's quadratic, right? Because we get to get that square term there. So let's go ahead and give me my quadratic values here. It's going to be -2, -1, 0, 1, 2, 4, 1, 0, 1, 2. Okay. So what do we do with x values?
Wait, shouldn't that be square, not 2?
It should be absolutely right. Yeah, I was just checking to see if you were like paying attention.
And they're the same?
Just kidding.
They're the same?
X stays the same. Anyone else see that?
No.
Okay. So it's just going to be -2, -1, 0, 1, 2.
So the other one we have to
And what happens to f of x though?
3 multiply
3/4 each, right?
subtract 9.
And then subtract 9. So 3/4 times my f of x, and then I subtract 9 from that. So you multiply first. Okay, what's 3/4 times 4?
1.
4 cancels, and you end up with 3.
Oh, yeah, 3.
So it's going to be 3 minus 9. And the next one stinks. It's 3/4 minus 9. It's going to be what? 8 and
8.2. Negative
8.25.
8 and a quarter.
Negative. Right?
Yeah, negative 8 and a quarter. Correct. Thank you. 0. That's not so hard.
Negative. Isn't it just negative?
No, it's just negative 9.
Negative 9. And guess what the next two are going to be?
-8.
Right. Yeah. Cool. So we can approximate that 1/4. It's not a big deal. So you got -2, -6, -2, -6, and -1, -8 and a quarter. -1, -8 and a quarter, something like that.
It's like a little
And then -9, 8 and a quarter. Wow. Aren't we like geniuses being able to graph these things? Come on. Just think how impressive you'll look at the parties doing this stuff, you know. Go to a nice little gathering, do some transformations. Sorry. Want to do this one? Wait, I mean, I like that one. That's can we do that one quickly?
Which one?
The one number 17? So, can you guys fill in the? Tell you what, let me walk around. I want to just see how you guys do this one. Fill in the parent function first, right? What's the parent function on this one? Absolute value, right? So this is number 17. For some of you, this may be your first flight all by yourself, right? See if you can do it. Did you do it? Number 17?
Are these like dashes? Is that so it's not the 4 1?
That's it. That's correct. Absolute value. Right. -2, -1.
This, but like positive, right?
Correct, because it's the absolute value
Yeah.
parent function. Right.
Is this like opposite of whatever this is?
It's not opposite. This is it's the absolute, here, I'll put it up there. The parent function is f of x equals the absolute value of x. So what it does is it always returns a positive value, right?
Mm-hmm.
And so it's not necessarily the opposite, but the x values that we put in, -2, -1, 0, 1, 2. And that's the same, those are the same starting values that we use for all the parent functions, all right? So far. Good. All right.
But
So,
then
so now the question is, what happens, what do we do to the, what are we doing to the y value and what are we doing to the x value in this function here?
okay, so for like an absolute value.
So I'm turning back the thing. Okay, so again, this is the absolute value parent. So the same, again, the template is always the same for the absolute value parent function. -2, -1, 0, 1, 2. You could pick other numbers, but these are the critical, these 5 critical points allow you to graph pretty much everything. And then the f of x is going to be the positive values of all these, right? So that never changes or hardly ever changes. So what do we do to the, what's happening to the x value? You're subtracting 4. And then the y value, we're multiplying by -2. So I'm like using the f of x just to get you used to it. Basically, we take the f of x value, multiply by -2 to get g of x. So minus 2 minus 4, you had that. Abby, why don't you give me those numbers?
-6, -5, -4, -3, -2.
All right. And then, Sebastian, why don't you give me the -2 times f of x numbers?
-4, -2, 0,
Okay. And that's the kind of thing that we would expect. All right. And so let's go ahead and graph it. -6, -4. Right. And then -5. Remember, always the first number and the last number. -5, -2. And then 0, -4, 0. And then again, so a slightly thinner, flipped, shifted to the left. That's what we would have expected, right? One more and you guys, I'll have mercy on you. Can we do, can you show me you can do a, you ready? These last two. This last, how about, which one do you want to do?
The 19 goes half.
Let's do the last two.
Okay.
Do the last two, and then that's, and then I'll, then we'll take a nice good a good break, all right? And then I have one little sniglet to add. Okay, don't look at me like that. Okay, so I'm gonna pause for those people that have headphones on, and see if you guys can do number 19 first. Okay, I'm turning on the recording for F block. I don't know if you guys check your numbers here and go ahead and check your graph. You can pause it now too, so you can check it. And once you're done, go ahead and move to last graph that I'm gonna ask you to graph at number 20. Now, also, you should be reminded, I just posted a quiz for a week from today. Okay, so we have one more section that's going to be on the quiz. I'm going to give you a little introduction to it today, but just be forewarned. Oh, no, it's recording. Okay, I'll turn on the recording again. Okay, everybody. So, so the x values, again, this is a parent function, quadratic parent function, right? So the numbers in the middle, identical to all quadratic parent functions. We're going to multiply by -1/4, and then add 3. So that gives us 2, 2 3/4, 3, 2 3/4, 2. So you get that symmetry. Every time you have the quadratic, you get the same symmetry. So you really only have to calculate 3 values. And then we're going to subtract 2 because up here we have the plus. And remember that we always shift opposite the direction of that value in the x value. So we're all good, right? I think we need to take a break. You guys want like a 25-minute break, I know, but can I just give you like a 7-minute break, and then I'll just give you, I just want to give you an introduction into.
Over in 7 minutes.
Is it really?
Yeah. So do you want to play?
Oh, we've been here that long? I mean, the time has just gone so fast for me, I guess. Okay. Okay, I'll tell you what. Let me let me give you the quick intro into the final piece. All right. While Jillian kills herself. Oh God, I swear to God, I owe you one on this one. I really do. I really do. I agree.
Wait, is it
Just someday you're gonna just tell me you owe us one, Mr. Scheidegger, and I will.
gonna be on the quiz on Monday?
This is going to be on the quiz not on Monday. It's going to be on the quiz on Thursday. But I just want to. Can I just show you this?
It's on Thursday.
I just want to show you. Okay, listen. This is not so bad. Okay. What I need you to be able to remember is something that you is something from the old days. This is called slope y-intercept form, right? Y equals mx plus b, right? So what is the b? B is where it crosses the y-axis, right? Y-intercept. And so what you're going to be doing, one part of your homework is going to be to look at a graph and see if you can determine the slope from the graph and the y-intercept from the graph, and then just plug in the values to create the equation. Yes?
That's a rise over run thing.
It is the rise over run thing. So here, let me give you an example. Oh, I'm just gonna blow through this one, right? So here's monitoring progress. You see this? You're gonna get questions like this. You'll get 3 of these. No, 4 of these.
On the quiz?
No, on homework. And the idea is to write the equation for this. So what we need is the slope in the y-intercept, right? So the slope is going to be, usually you could just join any 2 points like this. Do you guys see how I just did this? I made that step. And then I measure. On the homework, it's actually going to do that step for you. What is the rise in this one? Guys, we're almost done. So look at each box is going to be how much? Between 12 and 18 is 6. So the rise on this one, if you're careful, is actually 6. And the run is, look at the numbers down here. Who said 10? It is 10.
Wait, wouldn't the rise be 3?
Yeah, the rise is 3 because it's not.
Okay. Thank you. So what's so the rise of the run is going to be,
3 over 10.
okay, now be careful though, because is this a negative or a positive slope? Does it lean left or right?
It's negative.
It's negative. So it's going to be negative 3/10. What's the y-intercept?
18.
18. Now we've got M and B. We're home. We go y equals slope,
Negative 15.
and then we follow by an
Plus
x
18.
plus 18.
It's not as hard as I thought.
No, and I have like 5 of these to do on your homework, just to get you kind of started on this. Everyone, have an amazing weekend. Your work is on big ideas. If you don't know where, then just go to my essay and it'll tell you to go to big ideas, and you're going to be doing that assignment. And apologies to all those people that are moving their way out of a coma today.
Want me to show you?
Oh, now I can.